Hi friends, this is Rashekar, a GATE faculty for electrical machines. In this video, we are going to differentiate core type transformer and shell type transformer. Generally, transformer cores are three types. One is the core type, next one is the shell type, and third one is the berry type of core. Generally, berry type of core used in instrumentation transformers like a CTPTs. But in generally, there is no syllabus of berry type of transformer. So now we have to discuss about core type and shell type. Core type and shell type. So let's see here how the core type and shell type. See, this is the core type of transformer core, well known. And see how the shell type, let's see, this is the shell type of transformer core. This is the shell type of transformer core. See, these are called limbs. So in core type, how many limbs are there? In core type, we have two limbs. But in shell type, we have three limbs. In shell type, we have three limbs. Next one. These are called yokes. In core type, we have two yokes. Of course, in shell type also, we have two yokes only. And next one. Generally, in between these two, we are taking winding on this. We are taking winding like this. But here in shell type, the winding is placed on the middle limb. The winding is placed on the middle limb. See here two limbs are same in size. Here two limbs are same in size. Two limbs are same in size. But see here, the size of the middle limb is equals to 2 times of the size of the side limbs. 2 times of the size of the side limbs. This is lesser in size. This is double than that one. Of course, here the flux is same in the two limbs. But here, for example, if this is the flux phi, then 50% of flux is here and remaining 50% of flux is here. Nothing but here 5 by 2 and here 5 by 2. Here 5 by 2, here 5 by 2. Total flux 5 by 2 flux, 5 by 2 flux. Nothing but here single series magnetic circuit. But here double and parallel magnetic circuit. Single series magnetic circuit, double parallel magnetic circuit. These are the basic differences by looking at the diagrams. Apart of this, comparatively, comparatively, in which the winding requirement is more, in which the winding requirement is less. They will ask you question. In core type transformer, winding requirement is more, winding requirement is more, nothing but copper requirement is more. But in shell type transformer, winding requirement is less. Winding requirement, winding requirement is less. But here the insulation requirement, insulation requirement is less, insulation requirement is less, but here insulation requirement is more, insulation requirement is more. Here winding requirement more, insulation requirement less. Here winding requirement less, but insulation requirement is more, because both the windings placed on same limb. That's why here more insulation required. These are also normal things. Now very important things in between these two. Generally the core type is used for high voltage low current applications, high voltage low current applications, whereas shell type transformer used for, shell type transformer used for high current, high current low voltage applications, high current low voltage applications. Here high voltage low current applications. And also see here, if the flux is comes like this is called leakage flux. But here if the flux is comes like this and it is again returned to main path. Now tell me, in which leakage flux is more? Yes, as in core type transformer, in core type transformer, leakage flux is more, whereas in shell type transformer, leakage flux is less comparatively. Here leakage flux is more and here leakage flux is less. Leakage flux is less and here leakage flux is more. This is simply the difference between core type and shell type transformer, right? Now the very important last one. Which type of winding is used in core type? Tell me, which type of winding is used in core type? Very good. In core type, we are using concentrated winding. Concentrated winding. In core type, we are using concentrated winding. But whereas in shell type, we are using sandwich winding. We are using sandwich winding and here concentrated winding. Concentrated winding, sandwich winding. This is simply the core type and shell type. Very important, right? Here, number of limbs and yokes and area of limbs, single series magnetic circuit and double parallel magnetic circuit, winding requirement more, insulation requirement less, high voltage applications and leakage flux is more, and here we are using a perfect concentrated winding. These are the basic difference between core type and shell type transformers. Let's discuss about concentrated winding and sandwich winding. Concentrated winding and sandwich winding. Let's see, generally concentrated winding is like this. Like this. But in concentrated winding, we know that leakage flux is more. This is the disadvantage. Now we have to overcome this disadvantage. How we can overcome this disadvantage? See, to overcome this disadvantage, nowadays we are using, to overcome this disadvantage, nowadays we are using interleaved concentrated winding. Interleaved concentrated winding. Nowadays we are using interleaved concentrated winding. Sir, how it is? For example, see, for example, this is LV winding. Started here, but ending is here. This is LV1, this is LV2 terminal. For example, HV winding is, for example, taken here, started here, but ending is here. Like this. This type of winding is called interleaved concentrated winding. In interleaved concentrated winding, the leakage flux reduced by 25%. Compared to this one, here the leakage flux reduced by 25%. So only 75% of leakage flux is there. This is the advantage of the interleaved concentrated winding. Interleaved concentrated winding. Now, actually, the winding procedure is not like this. Actually, the winding procedure is not like this. Sir, how it is? The concentrated winding, how it is? See here, for example, this is my transformer core. This is my transformer core. We have to take a winding. So how we can take the winding? See here. First, we have to take the insulation around the core. First, we have to take the insulation around the core. This is the insulation on both sides. On both sides, separately, we have a insulation. Upon that insulation, we have to take the winding. Now, this is the winding over the insulation. This is the LV winding. This is the LV winding. Upon that LV winding, again we have a insulation. Again we have a insulation. And over that insulation, again we have a winding which is called HV winding. Which is called HV winding. The same procedure on another limb also. Here, the LV and HV is separated by insulation. There is no electrical connection. Those two are electrically separated, but magnetically coupled. LV and HV windings are electrically separated, isolated, magnetically coupled windings. Here, always LV winding should be near to the core. LV winding should be near to the core always, because to reduce the insulation requirement, always LV winding should be near to the core. And always HV winding far away. HV winding far away from the core. Far away from the core for easy tap changing. For easy tapping or tap changing. Easy tapping or tap changing. Always the tappings should be placed on high voltage side or low current side. Always the tappings should be placed on high voltage or low current side, because during the tap changing current should be minimum. If the current is minimum, then with less sparks we can change the tappings. Always the current should be minimum. In which current is minimum? On HV side current is minimum. So we have to take these tappings on HV side. For easy tap changing, HV far away from the core or outside. HV winding should be outside. LV winding is inside. LV winding near to the core to reduce the insulation requirement. HV winding far away from the core for easy tappings. This is simply about the concentrated winding phenomena. This is what? The concentrated winding phenomena. Right, okay? We are going to discuss about sandwich winding. Sandwich winding, nothing but the winding is like a sandwiches. Sir, how it is? One see here. For example, if the winding is first one LV, insulation, then after HV, insulation, then after LV, insulation, then after HV, insulation, then after LV. Like a layer by layer. Or for example, like this. First, for example, LV, insulation, HV, insulation, LV, insulation, and then HV. Like this. These are called sandwich windings. If top and bottom layers are not same, that winding is called asymmetrical sandwich winding. If top and bottom layers are same, that winding is called symmetrical sandwich winding. Asymmetrical sandwich winding and symmetrical sandwich winding. In generally, at balanced condition, N1I1 is exactly equals to N2I2. N1I1 is exactly equals to N2I2 at balanced condition. When unbalances takes place, especially in asymmetrical winding, axial unbalances will take place. When axial unbalances takes place, N1I1 is not equals to N2I2. N1I1 is not equals to N2I2, but by axial shifting, we can avoid this. By axial shifting, we can avoid this. And in symmetrical winding, generally radial unbalances will take place. Due to radial unbalances also, N1I1 not equals to N2I2. The MMFs are not equal. Then by radial shifting we can balance them. Here radial shifting and here axial shifting. Generally, this is about sandwich winding. How the sandwich winding is there? See here, how the sandwich winding is there. For example, shell type is like this. Here first we are placing the winding, which is for example LV. Then after insulation, again HV. then after insulation, again LV, then after insulation, again HV, like this, the winding procedure. Here the total winding is inside the core. Here the total winding is inside the core. That's why here cooling requirement is more. Cooling requirement is more. In shell type transformer, cooling requirement is more compared to core type. Compared to core type. Right? So this is about the shell type. Now I will ask you one question. Which of the following is a shell type? Which of the following is a shell type? Option A. Option A. The winding surrounded by core. Option B. Core surrounded by winding. Core surrounded by winding. Tell me which of the following is correct for shell type? For shell type, which of the following is correct? Winding surrounded by core or core surrounded by winding? Which is correct? See, this is the winding. This is the winding. This winding is in middle and core is surrounded. Here the winding is surrounded by the core. The winding is surrounded by the core. Winding surrounded by core is a shell type. What about core type? What about core type? Generally, in core type, this is the core and here we are placing the winding. The core is this one and the surrounding is winding. Here the core surrounded by winding, core surrounded by winding in core type and winding surrounded by core in shell type. This is simply about the core type and shell type transformers. I said you the last one is a berry type. Berry type. Berry type generally used in instrumentation transformers. Instrumentation transformers. Here we have a multi-magnetic circuits. Here we have a multi-magnetic circuits in berry type of transformer core. Right? This is simply about the shell type and its sandwich windings. Right? Thank you.